I'd like to recognize my co-authors, John Vredenberg and Jeff Sanchez. Jeff is here today. He's from Bitter Lake Refuge. Jeff, if you could just stand up. All right, Jeff Sanchez. All right, so I'm going to talk to you about process models and a thing that we've been doing throughout the Southwest on federal, state, private, what have you lands, a thing called wetland reviews. This came out in 1997, this paper. I want to recognize this. This is that Toffinol paper that came out about the natural hydrograph as a paradigm for ecological restoration. And the thing about this paper, I'm sure you're very aware of it, it was very seminal. It influenced a lot of river restoration. And the basic premise of this paper was look at the natural hydrograph. You can, you can do all these super hardcore IFIM, stream flow studies of fish, their needs, but really start off by looking at the natural hydrograph and the cues of it to understand what you need to restore in terms of an ecologic system. Really important paper. We've built on this, and we've built on this by incorporating out at all. I can't see this. Better. Okay. Building more physical process into it as well. How is the systems responding to those cues, and how do these systems work from a geomorphic physical standpoint? So what we've done is we've developed these Wetland-landform conceptual historic process models. It's a mouthful, but basically it's how do these systems work. Develop models that describe historic wetlands and landforms and physical processes associated with them. Develop conceptual models of how these processes have been disrupted. That's just as important as understanding how they used to work. It's how they've been disrupted. And use these models as a means for assessing potential for improving wetland and riverine restoration and management. We've developed this landform directory, which I will show you, based on geomorphic mapping as a structure for conceptual models, and a very rich spatial data set. But I want to also emphasize that this process can be different scales. You can go to the Cadillac version, but you can also go to the VW bus, and they've all been very beneficial. And these conceptual models are iterative, and they require honing, and they're open to scrapping. So these are models we're throwing out there, hypotheses to work with to understand these systems. All right. Okay. So just for instance, here's Bitter Lake Refuge near Roswell, New Mexico. This is both the two landform maps of the refuge. Here is the refuge in 1939. Here it is in 2005. And this is like a story we see everywhere. And it's really amazing as we've done these reviews across the Southwest, West, and even East. These systems have been so yanked with, and so we're really operating in a post-apocalyptic sort of world here, guys. I mean, this isn't, we've seen the fall, and we're trying to restore some sort of a semblance of function to these systems. So here it is in 39, a very wide river, very meandering, connected, a spring system here. So this darker green is perennial springs. The lighter green is a ephemeral spring system, and a very connected system and very dynamic. And then in 2005, this is before we did a lot of restoration on the Pecos itself, a very channelized river. Some juicy stuff still going on, but much more scaled down, and a spring system that was impounded. And I'll describe that later. So just to sort of give you a glimpse of what we're talking about here. For the wetland review, this is a community process that we've developed. It's an abiotic process approach to land management questions that really looks at physical processes and understanding these physical processes. It's collaborative. It's grassroots. We involve anybody from the private landowner to the research biologist to the backhoe operator, really ensure that we get a broad spectrum in this process, in this workshop. It's site-specific and spatially scalable. So it can be from an impoundment, one wetland, to a whole irrigation district. And it's driven by specific management questions, and every review has been different. I'm going to say we've done about 25 of these over the past 8 years, and each one has been really interesting, and each one has been different. So typically the process format is there's some scoping with a small team that gets together in front of it. What are the main management questions? What are the concerns? And then there's data preparation, and this is usually the heavy lifting that's done behind the scenes. But it can be light lifting if you can still do this process with less data, and it's still very valuable. And then we typically have a 3-day workshop. Day one is overview talks, getting people familiar with the landforms, the historic process, familiar with the data set that we provide them, and I'll show you what this data set is, and then field visits. And then day 2 is more field visits, and then these review exercises. There's 2 exercises, and I will show these to you. And then day 3 is more of the review exercises and next steps. And then it's all wrapped up into some sort of report. Whatever, depending upon the questions, depending upon, from full-on ESA stuff to just private land stuff, it's been very varied what the final products have been of this. So to show you what this process is, I'm going to run through this one that we did out in eastern Oklahoma, and this is a really cool place. This is the Sequoia National Wildlife Refuge, and it's a confluence of the Arkansas and the Canadian rivers that us in the West know well, but it's where they come together. And here's a photo in 1940, so it was a very dynamic system, big bars, and then today, of course, like many of our systems, it's very static. There's a big lake there for navigation, Kerr Lake. And this is 2008. And I want you to sort of focus as I show you this stuff. Right in here are some areas that there were some questions about wetlands. So one thing that we do for this is that we do these geomorphic maps. We do what it was like, try to get some sort of native map of what the landforms were like historically, and then a modern map of what they are now. So what I showed you with Bitter Lake. We find that is really important as a backbone for discussing these processes. So here in 1940, the blue is a river, the yellow is open sandbars, the tan is vegetated sandbars, and then this is more of a terrace, an area that would get flooded. And again, there's this area of concern. And then we developed a landform directory for that, with like, okay, here's the 1940 landforms, what I just showed you. And for instance, if you go to the directory and you say, well, that area that we were looking at for the wetlands is a 1940 landform was a Holocene scroll bar, and we have a definition of it, which it's a accretionary bar deposit. The texture was variable, primarily fine to medium sands. The topography was generally lower towards the historic channel, higher as you get further away from it. And the hydrology inundated during very high flood events. So you sort of come up with these conceptual models of where that spot on the landscape, how it used to function. And then we look at the modern. So this is the world that we deal in, and it's a lake, and here's the area, and these landforms here are the lake, the open water. This is more of a swamp landform that's moved in there, and a dry terrace, just a dry, non-flooded area. And for instance, those areas in the modern, the forested swamp, it's a swampy, heavily forested topographic areas within 1 or 2 feet of the lake. The texture, the topography, we outline that, and we do this in front of the review as a basis for the exercises of the review. Though again, these are conceptual models, and they often get honed through the workshop itself. And then other stuff that we typically have done, that we found really useful, is historic imagery is just gold. And there's this great set from the 30s. There's even stuff that goes back to the 1910s, 1918s. But that stuff's really important. And getting that stuff rectified into GIS and working with a series of photography has been really helpful. Landform maps that I showed you and directory, vegetation maps, and doing historic versus modern vegetation maps, LiDAR is gold, topographic data for the modern, just so you can understand when you talk about management or restoration, what you need to do, soils maps, hydrologic information, so that's the hydrograph stuff, the historic hydrograph versus the modern, the surface water hydrograph. We also look at groundwater hydrographs, and try to come up with how groundwater used to function historically, and then water management information, species fact sheets. It's just a chunk of data that we bring to this stuff. And we present this stuff to the group to run through these exercises, which I'll show you. Just for example, though, in terms of some of this data, like this is the story for this area we were looking at, that in 1945, here's the hydrograph. What's going on with this? Hydrograph for the Arkansas River, and it was very spiky, very variable and bimodal. And then the modern hydrograph is this, it's flatlined. It's just it's a reservoir now for navigation. So understanding those changes is really critical. And then we run through these exercises. These are the rough exercises. I just show you what they look like for each landform. We come up with, here's that landform that those wetlands are on, and the groups do this. And you come up with these group exercises to do this, and you go out and look at the sites, and you test it, and you auger holes in, your soil pits, if you're lucky, you get a backhoe out there. And you look at, so you come up with historically, here's how it used to function. Currently, it functions this way, physical processes. And it's really based on all this stuff. Another part that's really cool and really critical is looking at the historic documentation and knowing, these descriptions of the landscape historically from, different documents. And then the physical structure, what it was historically, what it is today, and biotic components, historic versus current. So this is done in group, but with all the data as an assistant to it. And then we'll scale in and look at specific wetlands or management areas typically, but not always. That's what we tend to do. So you may look at this wetland here and come up with, here is your potential management strategy in an early fall flood up. And what would we predict the abiotic response to be? And predict the biotic response. And monitoring activities to consider. And obstacles to implementation. So just run through this exercise and discuss it in group and come out with this in this table format that you then feed into a document of some sort for recommendations to try. It's not like we're coming up with an answer, like here's how you need to restore it, or here's what you do, but it just gives a suite of alternatives, and it really sets up a wonderful sort of adaptive management framework because you have your monitoring built into it with your hypothesis. Your hypotheses here. And, so it lets you run through that and hone it as you go and build on it. So I'm going to just turn now to finish up here just to show you some stuff at Bitter Lake, because I think Bitter Lake Refuge is a good example of a place where they've done a lot of this stuff, where they've taken this sort of framework, this lens of looking at, like, let's try to turn stuff back to the historic, and it's been pretty interesting. So again, here is the river in 1939, and here it is in 2005, the river and the wetlands, and these are impoundments. I'm just going to show you that. And again, Jeff Sanchez is the biologist out there, has done a lot of wonderful work out there. So on angle here, looking from the southeast to the northwest, here are the wetlands, the impounded wetlands. You see these impoundments that were put in, this wetland system, and then the river in the front, the Pecos River. I'll talk about both systems briefly. The wetlands were managed as a fishery from 1940 to 1984, and we've seen this. I've seen this all over the place where, a lot of folks tried to make systems something they weren't. And this one became very salty. It didn't work as a fishery ultimately. There was probably a time where it was pretty good, and it was probably excellent for a while, but then it really crashed. And the last stocking occurred in 1984. So what we did this in the 90s actually. As part of a water right, a reserved water right for this refuge, we took what was once the hydrograph was much more flatlined before. Just it was like checked up, keep these impoundments full, keep as much water there as possible. We tried to dry these things up and then pull them back up, and we tried to make that as part of the ability to do that as part of a reserved right. And they realized the importance of returning this natural hydrograph to the system. And so, here's just so you a picture of what the system looks like in the winter. Sandhill cranes, light geese, so those wetted areas in the winter were really important. And it was important to check it up in the winter because historically they would have had that naturally, but the groundwater's dropped in the area. So it's an important way to sort of mimic that historic flood up. But then, this is a Bitter Lake itself, but this sort of example of some of the salt flats out there. Drying the system up was also equally important, and this wasn't done. And this is really good for some of the native veg communities out there. Here's this Pecos sunflower, which is a threatened species, and federally threatened. Inland saltgrass and alkali bulrush, did I get that right? The bulrush in the front. And this vegetative community is really beneficial for this community out there that was being drowned out previously and salted out previously because the salt was being held in the system. It wasn't flushed through it. And then a side benefit, I always do this in my stuff. I always look for these societal, because we're always pushing against reasons why we can't do stuff. That type of management actually benefits the water budget too. It returned a bunch of water to the system because we were draining these wetlands. And it has some estimates on that. Similarly, a colleague of mine, Will Tinter, will talk tomorrow on Bosque del Apache and some of the restoration benefits of clearing salt cedar and returning mosaic and the benefit of that. 5 minutes, okay, I'm good. The sensitive species of the refuge. There's amazing, tons of tiny creatures out there. It's really cool. And doing this type of management, we started management that was really beneficial to these species. Here are these three endangered snails, endangered fish. And so one thing the refuge also did was put a berm up around and isolate some of these springs. And that was really cool. Lots of really beneficial. And just returning the system back. Jeff is really involved in this project, and I am too, but Jeff, it's his idea of actually trying to restore some of that spring habitat in the Rio Hondo, isolating an old channel there. Here's where this amphipod shows up now, the triangles and Since the restoration project has been implemented, which was about 6 months ago, the circles are places where it looks like potential habitat. Spring eyes coming up. And then we've also restored the Pecos River, something else we worked on, so I'm going to put that in the same context. We reconnected this historic channel and removed a bunch of tamarisk and lowered banks and removed a bunch of tamarisk from the north track. And so we've done about 12 river miles there. That's sort of the bottom line, and done a bunch of work. And that was when we were definitely pushing up against all these reasons why we couldn't do it. It was one of those things sort of like the Colorado River one. It was a real amazing event. It happened in 2008 when all the stars aligned and we were able to do this stuff. But, the river was channelized for flood control. Here's the tamarisk, our friend. And it was channelized for flood control, but old school flood control, right? Keep the water in the river channel, keep it out of sight, out of mind, which has its consequences when there's floods. The channel, because of reservoir operations, you developed natural levees with tamarisk along them and isolated this area from the floodplain. Well, and I would argue, and we've actually modeled this in the Rio Grande, that by doing that, you're actually increasing flood risk because your spiky flows that are out there stay in the river channel, and then your next abutment or bridge downriver get blown out. No mechanism to put the brakes on it. So we wanted to reconnect the floodplain. Went out there, we yanked a bunch of trees, lowered a bunch of bank lines, and then reconnected the floodplain. And so it just looks much more like it did historically, much more open. It's a really amazing place, beautiful, beautiful area. And this, I would argue, is much better flood control. You got a connected floodplain. You got a way to put the brakes on floods. So that's what I've got. So mimicking historical conditions starts with you. Emiliano Zapata there. So I don't know if I have any time for questions, but okay. Yeah. Yeah. I would say that there's restoration potential everywhere. I almost sound too groovy or whatever, but I mean, we work with so many systems that have been so degraded, and it's sort of like the Colorado River thing. When you return these functions, there's resiliency everywhere. So there definitely is. I mean, there's it's channelized down there, but I'm not super familiar with it. But I guess just generically, I would say there's potential there. I mean,
but you're not aware of anybody that's trying to work down there now?
I'm actually not. No.
All right, thanks.
Yeah.
Of course, up above you, you have the, what is it? I forget the major dam up there, Fort Sumner.
Fort Sumner, yeah.
Dam, which of course is trapping all your sediment. Are you still dealing with a degrading system, or is there enough sediment input otherwise? Because otherwise you're playing the game of every floodplain you create is constantly.
Yeah, good question. The thing that's really cool about the Pecos is below there are major tributaries that come in that dump sediment, and also during the fall and the summer, the monsoons, dump big floods. So that sort of returns to the dynamics of the system, really critical to it, really makes it work. And actually the fish species that tend to be living in the Pecos now and haven't been extirpated, like the silver minnow used to be there, well, it's much more keyed into, just one possible keyed into spring runoff. Spring runoff's not really part of the system, but a lot of them are much more keyed into the summer storms. But yeah, good question.
Thank you. I kind of have a technical question. How do you use those historic photos? What kind of procedure do you use for mapping those communities, geomorphology?
Good question. Yeah, I base it off of this work that was done originally in the Middle Rio Grande by Lettuce and Associates, and I can get you those documents. We come up with a nomenclature, and it's really important. I was trying to standardize that stuff and make it so it's a consistent one. It's a really fun exercise to do, but it is critical to have that. And I would say I'm putting together a white paper on the wetland review process, and that will be available. So folks, it's just a way. And again, you don't have to do the Cadillac. You can scale it anyway, but it's just a really good way to talk about restoration, to really keep that lens on about how these systems used to work.